Welcome to Spec Talks. I am Shravya from Cybersecurity and my team member Jeevani. Our topic is directory structures. We made this PPT under the guidance of Dr. M. Prasad sir, Associate Professor of Department CSC.
Good morning, sir. Today we are going to present our OS course activity, which is directory structures. Now, coming to the definition, directory structures in an operating system provide a hierarchical organization for storing and managing files and directories. They typically start with a root directory and allow for efficient data access, organization, and navigation, simplifying file management and access control. Directory structures are essential for modern computing environments. On a computer, a directory is used to store, arrange, and segregate files and folders. It is similar to a telephone directory in that it just contains lists of names, phone numbers, and addresses rather than the real purpose. It uses a hierarchical structure to organize files and directories. On many computers, directories are referred to as drawers or folders, much like a workbench or a standard filing cabinet in an office. There are four types of directory structures. They are single level directory, two level directory, tree structure, and acyclic graph structure. Now, coming to single level directory, the simplest directory structure is the single level directory. All files are contained in the same directory, which is very easy to support and understand. A single level directory has significant limitations. However, when the number of files increases or when the system has more than one user, since all files are in the same directory, they must have unique names. If two users call their data file test, then the unique name rule is violated. For example, in a programming class, 23 students called the program for their second assignment program 2. Another 11 called it assign 2. Although file names are generally selected to reflect the content of the file, they are often limited in length. The MS-DOS operating system allows only 11 character file names. Unix allows 255 characters. Even a single user on a single level directory may find it difficult to remember the names of all the files as the number of files increases. It is not uncomfortable for a user to have hundreds of files on one computer system and an equal number of additional files on another system. In such an environment, keeping track of so many files is very difficult task. Here we can see the pictorial representation of a single level directory. Now coming to the advantages of the single level directory. The main advantage of a single level directory is that it is very simple to implement. Since all the files are present in the same directory, in case the number of files is less, then searching for a particular file is faster and easier. Simple operations like file creation, search, deletion, and updating are possible with a single level directory structure. The single level directory is easier to understand in practical life. Now coming to disadvantages of single level directory. In case we want to organize the files in some groups, it is not possible to do so since we cannot create subdirectories in single level directory. Two file names cannot be the same. In case two files are given the same name, the previous one is overridden. If the number of files is very large, searching a particular file is very inefficient. Segregation of important and unimportant files is not possible. The single level directory is not useful for multi-user system. There may be chance of name collision because two files can have the same name. Searching will become time taking if the directory is large. This cannot group the same types of files together. Now coming to two-level directory, a single-level directory often leads to confusion of file names between different users. The standard solution is to create a separate directory for each user. In the two-level directory structure, each user has their own user file directory UFD. Each UFD has a similar structure but lists only the files of single user. When a user job starts or user logs in, the system master file directory is searched. The MFD is indexed by username or account number, and each entry points to the UFD for that user. When a user refers to a particular file, only his own UFD is searched. Thus, different users may have files with the same name as long as all files names within each UFD are unique. To create a file for a user, the operating system searches only that user UFD to ascertain whether another file of that name exists. To delete a file, the operating system confines its search to the local UFD. Thus, it cannot accidentally delete another user's file that has the same name. The user directory themselves must be created and deleted as necessary. A special system program is run with the appropriate username and account information. The program creates a new UFD and adds an entry for it to the MFD. The execution of this program might be restricted to system administrators. The allocation of disk space for user directories can be handled within the techniques. Now, if we see the picture, D1 is the master directory and D11, D12, D13, D14 are the user directories of master directory, and F1, F2, F3, F4, F5 and F6 are files of the user directory. Advantages of two-level directory are: the main advantage is there can be more than two files with same name and would be very helpful if there are multiple users. The security would be there which would prevent user to access other user files. Searching of the files become very easy in this directory structure. There can be two files with the same name in two different user directories. Since they are not in the same directory, the same name can be used. Grouping is easier. A user cannot enter another user's directory without permission. Implementation in two-level directory is very easy. Now coming to disadvantages of two-level directory. One of the main disadvantages is one user cannot share a file with another user. Even though it allows multiple users, still a user cannot keep two same type files in a user directory. It does not allow users to create subdirectories. As there is advantage of security, there is also disadvantage that the user cannot share the file with the other users. Unlike the advantage, users can create their own files. Users don't have the ability to create subdirectories. Scalability is not possible because one user can't group the same types of files together. Now coming to storage structure in operating system. Basically, we want the programs and data to reside in main memory permanently. This arrangement is usually not possible for the following two reasons. First one, main memory is usually too small to store all needed programs and data permanently. Main memory is not a volatile storage device that loses its contents when power is turned off or otherwise lost. There are two types of storage devices. First one is volatile storage device. It loses its contents when the power of the device is removed. And the second one is non-volatile storage device. It does not lose its contents when the power is removed. It holds all the data when power is removed. Secondary storage is used as an extension of main memory. Secondary storage devices can hold the data permanently. Now coming to hierarchy of storage. Storage devices consist of registers, cache, main memory, electronic disk, magnetic disk, optical disk, and magnetic tapes. Each storage system provides the basic system of storing a datum and of holding the datum until it is retrieved at a later time. All the storage devices differ in speed, cost, size, and volatility. The most common secondary storage device is a magnetic disk, which provides storage for both programs and data. In this hierarchy, all the storage devices are arranged according to speed and cost. The higher levels are expensive, but they are fast, As we move down the hierarchy, the cost per bit generally decreases, whereas the access time generally increases. The storage system above the electronic disk are volatile, which are those below are non-volatile. An electronic disk can be either designed to either volatile or non-volatile. During normal operation, the electronic disk stores data in large DRAM array, which is volatile. But many electronic disk devices contains a hidden magnetic hard disk and a battery for backup power. If external power is interrupted, the electronic disk controller copies the data from RAM to the magnetic disk. When external power is restored, the controller copies the data back into the RAM. The design of a complete memory system must balance all the factors. It must use only as much expensive memory as necessary, while providing as much inexpensive, non-volatile memory as possible. Caches can be installed to improve performance, where a large access time or transfer rate disparity exists between two components. This we came to an end of our topic. This is presented by Jeevani and Shravya of Second Cybersecurity. Thank you.